Hello, geometry. This is lesson 4-2, triangle congruence by side, 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 and side, angle, side. So instead of having to always prove triangles by finding the 3 congruent angles and 3 congruent sides, we can use these shortcuts here to also prove that 2 triangles are congruent. So the first one, side, 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 can be abbreviated by SSS. Exactly what it sounds like. If 3 sides of one triangle are congruent to 3 sides of a different triangle, then they are congruent. So looking here, AB is congruent to DE, there's one pair. BC is congruent to EF, there's my second pair of sides. And then AC congruent to DF, there's my third pair of sides, so I have 3 pairs of congruent sides. So therefore, my triangles are congruent. So that's SSS. And then the other one is side, angle, side. Again, this one's pretty straightforward, but there's one catch. And that catch is if 2 sides and the included angle, circle that, remember it has to be the included angle of one triangle are congruent to the 2 sides and the included angle of a different triangle, then those triangles are congruent. So let's break this one apart a little bit. Here's my side. AB is congruent to DE. There's my side. They're telling us angle A is congruent to angle B. There's my angle. And then they're also telling us that AC to DF, there's my other side. So hopefully you notice here that this included angle, guys, it's the angle that's formed between your 2 congruent sides. Do you see how the 2 sides that are congruent form these angles here? That's the included angle. Okay? So let's practice that included angle business. This isn't in your notes, so just listen carefully. So it says, what angle is included between sides BC and CA? Well, just looking at that picture, the only angle that's even formed is C. So angle C. Just looking without a picture, what's the letter repeated in both segments is C. So all signs point to C being the included angle. Okay, let's try another one. What angle is included between AB and BC? Well, my 2 sides form and touch at vertex B, so angle B. Again, what's the letter being repeated in both segments? B, B. Again, we have B. Okay? What would you use? Would you use side, 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 or side, angle, side to prove the triangle's congruent? If there's not enough information, then write not enough information. So let's see here. I have one side congruent. We have a pair of angles congruent, and then another side congruent. So we have side, angle, side. Okay, guys, again, you notice that these 2 sides make the angle that is congruent. That's your included angle. Okay, hopping on over to B here. Here's a side congruent to that side, so there's one side. We have a congruent angle pair. And then I have another pair of congruent sides. So, side, angle, side, right? Wrong. Look. These 2 angles, or 2 sides touch right there. Is that my congruent angle? No, it's right here. So this is not the included angle. So we don't have enough information. Not the included angle. Okay, see here. Let's check it out. One side. 2 sides, 1, 2, 3, I have 3 pairs of congruent sides, so that must be side, side, side. Now on to D. 1 side, 2 sides, 1, 2, 3 congruent sides, side, side, side. Or if you want to get tricky here, we know that these are vertical angles. Here's a congruent pair of sides. Here's another pair. So you could have done side, angle, side as well. Okay, ideally I want you to try these on your own, so please pause the video, even though I know you probably won't want to do that, but you're not going to learn unless you try them on your own, so pause it, check your answers, what I put up here. All right, here we go. A, what would you use? Well, let's look here. Here's a pair of congruent sides, there's my side. We know that all right angles are congruent, so there's my angle. Then I have another pair of congruent sides. So I have side, angle, side. This one here, pair of congruent angles, 1 pair of sides. Do we know our shortcut for just 1 side and 1 angle? Nope, not enough info. Moving on to C, 1 pair of sides congruent, 2 pairs of sides congruent. We now have 3 pairs of congruent sides, so by side, 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 those triangles are congruent. And then our last one here, 1 pair of sides congruent, pair of angles congruent, and then another pair of sides congruent. So side, angle, side, right? No, it's not. Is this my included angle? Nope, it would have to be a different color. This side here, but we don't know that, so we don't have enough information. Not enough information. What other information do you need to prove triangle ABC is congruent to triangle ADC? By side, angle, side. Explain. So let's first talk about what we do know. I know that angle BCA is congruent to angle ACD because they're both right angles. So we have our angle, like this. Got our angle checked. We also know that AC is in both triangles and it's congruent to itself, so there's 1 side. So the missing piece of information would probably have to be that BC is congruent to CD. So BC is congruent to CD would be our missing piece of information to get that third or that second side. So we know again that AC is congruent to itself. These right angles are congruent. So this side there would have to be congruent in order to use side, angle, side. So again, they start us off nice. We get a nice flow proof to start off our lesson. Oops, that is not ideal. Okay, there we go. So it says complete the flow proof. Given BC is congruent to BF and CD is congruent to FD. So before you even worry about this whole flow proof business, look at your picture. Just kind of digest it so you can figure out where you need to go. Do we know any angle measures? No, we are not given anything. So now you should think, hey, if I don't have any angles, I'm resorting to side, side, side. Can I find a third pair of congruent sides? Well, sure. BD is in both triangles, and you know that it's equal or congruent to itself. And there you go. We have our 3 pairs of congruent sides. So BC is congruent to BF. That's given to us. There's my first S. My second S, CD is congruent to FD. That is also given to us, right? They marked it for us. Now we're writing in our third side, BD is congruent to BD. By what property is that again? The reflexive property. And there's my third pair of congruent sides. So now we can conclude that these two triangles are congruent by side, side, side. Okay, now we take the trading wheels off a little bit, and now we have to write our own proof. Okay? So let's set up our table here, our statements, and our reasons. Okay, so let's just brainstorm. Let's see what they give us, mark our picture, and see where we can go, okay? So AJ is congruent to AZ. Mark that. Here's AJ, and it's congruent to AZ. Okay? So that's one pair of sides. Then it tells us AD is congruent to AM. Here's AD, here's AM. There's my second pair of congruent sides. Can we conclude anything about JD and MZ? No, we can't. But hopefully you're thinking, oh, I have vertical angles here, right? I know that this angle is congruent to that guy, and there's my angle. So what letters do we have there? Side, angle, side. So let's write that down. Side, angle, side, and we'll fill in the blanks. So step one, what's my first side that's congruent? Right here. Different color. AJ is congruent to AZ. What's our reason? Well, plain and simple, it was given to us. Okay, my angle, what's my angle? We have angle JAD, angle JAD is congruent to angle ZAM, angle ZAM. Why? What kind of angles are those? Vertical. So by the vertical angles theorem, they are congruent. And what's my second pair of congruent sides? AB is congruent to AM. Why is that? Well, that was also given to us. Now we have said enough to conclude that triangle, remember you always end with your proven statement. Triangle ADJ is congruent to triangle AMC. And that is by what reason did we use? Look over here, side angle side. That wasn't too terrible, was it? Only 4 steps? Okay, and then our last example for this video lesson. Let me do a little rearranging. Okay, so again, let's set up our page here. Statements, reasons. Now let's just mark up our picture based on our givens, okay? So it says PO is congruent to SO, PO is congruent to SO. That's a side. And then it tells you that O is the midpoint of NT. Here's NT and O's in the middle. We know that O splits that segment into 2 congruent pieces. So there's my other side. And again, we have these intersecting lines which form vertical angles, and we know that those are congruent. So if I look at my letters here, I have side, angle, side. So let's write that over here. Side, angle, side. So our first side, PO is congruent to SO. Why can we say that? That was given to us. 2, our angle, let's look at our angles here. PON, angle PON is congruent to angle SOT. Why is that? Well, those are vertical angles, so by the vertical angles theorem, they are congruent. So now we kind of have some filler information, right? Because I can't just jump and say ON is congruent to TOT. I first have to give this given information, because otherwise we'd just be making it up. So my third step is O is the midpoint of NT. And why can we say that? That's given information. And now we can jump and say, speed this up a little bit, that OT is congruent to N and O. So my last pair of congruent sides is NO is congruent to OT. And why can we say that? That's definition of a midpoint. So now do I have enough information to prove my triangle's congruent? Sure do. So triangle PNO is congruent to triangle STO. That is by, look over here, folks, look over here. What letters do we have? Side, angle, side. Okay, you're only going to get better at these when you practice them. So your homework for tonight, I'll try not to talk so loud because I'm right by my computer. Here we go. There it is. It's kind of split up. So here's Monday. You're working on page 230 through 233 and doing these questions here. Good luck. We will do the last example together tomorrow in class and then have day 2 on just working on side, angle, side, and side, side, side. Thank you for watching. I will see you tomorrow.